Hey everyone, today I'll be explaining the lesson gases in Earth's atmosphere. It's actually a really easy lesson, but yeah, you have to focus. Now, these two slides are talking about this graph right here. This graph represents the composition of dry air. Dry air. What does dry air mean? Dry air means that it does not contain any H2O, any water vapor whatsoever, so it does not contain water evaporated in it. Now, the composition of dry air is very important. You have to keep in mind that nitrogen is the most, as it contains 78%, and oxygen is followed by nitrogen, which is 21%, and then argon is 1%. Now, the composition consists of three elements, which are nitrogen, oxygen, and argon. Also, if you think of this as pressure, okay, if you think of this whole circle as the pressure of dry air, then nitrogen has the most pressure, or the partial, as we call it, partial pressure of nitrogen is the most. So the total pressure of dry air is equal to the partial pressure of nitrogen, partial pressure of oxygen, and the partial pressure of argon. Now, what I just said was called Dalton's law, which basically states that the total pressure is equal to the sum of the partial pressures in the container, etc. يعني if I have, for example, element A and B and C, the total pressure is the addition of the partial pressure of A and the partial pressure of B and the partial pressure of C, and so on. If there is more, you add the more. Now, this practice question just tests your knowledge of what has been stated before in Dalton's law. Let's read the question and analyze what they want. Air, or if it's Dalton's law, then there is going to be P total, which is the P total of air, is equal to, contains oxygen, nitrogen, argon, and trace amounts of other gases. So the total pressure, which is air, contains the partial pressure of oxygen plus partial pressure of nitrogen plus partial pressure of argon plus partial pressure of other gases, or other. What is the partial pressure of oxygen? They want this. This is unknown. We want this. And they give us that the total pressure of the air is 101.3. So we just substitute 101.3 and check the unit. This is kilopascal. This is kilopascal. This is kilopascal. And this is also kilopascal. So it's okay. They all have to be the same units. So 101.3 kilopascal is equal to the partial pressure of oxygen plus nitrogen is 79.1 as stated here, because it said nitrogen, argon, and other gases. So this is nitrogen. Then argon is 0.9 plus 0.9 plus 0.04. Now, to solve this, we just use a calculator to find the partial pressure of oxygen, which is going to be 101.3 minus 79.1 minus 0.9 minus 0.04, or it's going to be 21.26. What's the unit? Kilopascal. And this is your answer. Now, what is diffusion? Diffusion is basically the movement of particles from areas of higher concentration to areas of lower concentration. So higher to lower, you have to keep that in mind. Why do they do that? They want to reach equilibrium. So this is their goal. Their goal is to reach equilibrium. Now, for example, here it states an example, which is if you take a bottle of perfume and you go to the edge of a room or the corner of a room and you spray it, then this is how it's going to look like at first. These particles that have just been sprayed are going to be very close together, and that is going to form the area of higher concentration. To reach equilibrium, because this is higher concentration of the perfume particles, here is higher concentration of the air particles. To reach equilibrium, these are going to have to go and spread to all other parts of the room, which is going to make the room look like this, with even concentration of both perfume and the air particles. Graham's law states that the rate of effusion, now Graham's law is an actual formula, it states that the rate of effusion of, for example, particle A to over the rate of effusion of particle B is equal to the square root of the molar mass of the opposite, so B, over the molar mass of A. So it's the rate of change, or the rate of effusion, is equal to the square roots of the inverse of the molar masses. This is a question just to test your understanding. It says that how much faster, so they want the rates. So rates of helium over rates of nitrogen is equal to, they want how much faster, they want the rates at the same temperature. They give us the molar mass of helium, the molar mass of nitrogen, so square root. We don't put the helium first, we put the nitrogen first because it's the inverse. So we put 28 over 4. Now when you plug this into the calculator, it's going to turn out to be the square root of 7, or approximately 2.64. Now, there is a difference between diffusion and effusion. They both, first let's look at the similarities. They both are talking about the movement of particles where of higher concentration to areas of lower concentration. But the difference is very simple, which is effusion, it occurs through tiny holes, as you can see here. يعني هنا عادي, you just remove the barrier and it just flows all around. But here, there is a small hole where the particles move through. Here is a Q&A and we're gonna try to solve it together. How does diffusion move? We just said right now that it moves from areas of higher concentration to lower concentration, so this is the correct answer. Here, what makes up most of the dry air on Earth? As stated in the graph that was shown in the very beginning, nitrogen is the most at 78%. And this law, P1 plus P2 plus P3 is equal to P total. It's made by who? It is made by Dalton, because Graham's law is the rate of 1 over rate of 2 is equal square root of molar mass of 2 over molar mass of 1. What is the partial pressure? Partial pressure is the amount of each substance in the total substance. And that is it.